What if your workflows ran themselves and your data just knew where to go? Meet the tech stack making it real. Apache Airflow and MongoDB. Airflow gives you clean, scalable orchestration. MongoDB handles the data. Fast, flexible, reliable. In this video, we'll show you how to connect them the tech brain way.
Let's get started. Learning Airflow is essential for servability and flexibility. It allows you to manage complex workflows and data pipeline with ease. Airflow integrates with various systems, from databases to cloud platforms, enabling you to create custom solutions. With its active community, you have access to extensive resources and support. Airflow reduces manual intervention, minimize errors, and speed up data processing. Professionals with Airflow expertise are in high demand as companies seek to optimize their data operations. Central to Airflow is the concept of a directed acyclic graph, or DAG. A DAG is a collection of tasks arranged in a specific order, clear dependencies between them. Every edge has a defined direction, showing the sequence of tasks. There are no loops, ensuring tasks execute in a one-way, predictable order. DAGs provide clarity and visualization of your workflows, facilitate modularity by isolating tasks, enable scalability for managing complex interdependent tasks. Airflow comes with various operator types that help you perform different tasks. We have action operators such as the Python operator or Bash operator, which execute specific functions or scripts. We also have transfer operators. They move data between systems, for example, from S3 to Redshift. Lastly, we have sensor operators. These wait for a certain condition to be met, like the presence of a file. For example, a Python operator can extract data from a source, transform it, and push the results to XCOM, while a Bash operator might trigger a shell script to move files. In any data pipeline, the ETL process is crucial. The first process is to extract, which gather data from various sources. The second process is to transform, cleanse, enrich, and convert the data into a usable format. Then lastly, to load, importing the processed data into a target database or data warehouse. Automating this process ensures efficiency, data integrity, scalability, and cost effectiveness. Let us take a closer look at Airflow's architecture. DAGs, which is the backbone of Airflow, they define the workflow and task dependencies. Operators. These are the building blocks of task, whether it is a Python operator, Bash operator, or even a custom operator. We have sensors. They monitor external systems of conditions before moving forward. Lastly, we have the UI and monitoring. Airflow provides a powerful web interface for monitoring workflow execution, logs, and task dependencies. In this project, we are going to set up and run our Apache Airflow project using the Astronomer CLI. Astronomer CLI is a popular platform that makes deploying Apache Airflow simpler and more scalable. First, make sure you install Astro CLI on your machine, as shown on the screen. For Mac OS user, you can use the command brew install Astro. Run Astro dev init in your project directory. This command sets up the necessary Airflow project files and Docker configuration. Now, let us go through a Python script that extracts sample data from a JSON file, transforms it, and load it into MongoDB. our Airflow project using the Astronomer CLI for a smooth development experience. Let's start by looking at our Python script. This script defines an ETL pipeline with three main stages: extract, transform, and load. Our goal is to pull data from a JSON file, transform it by performing type conversions, and then insert the transformed data into two MongoDB collections using the Mongo hook provided by Airflow. First, we import all the necessary modules. We use OS and JSON to handle file operations and JSON data. Airflow libraries like DAG and Python operator help us schedule and execute tasks. The Mongo hook from the Airflow Mongo provider let us connect to MongoDB. We also import date utilities from the datetime module to define our schedule and retries. Next, we define an on-failure callback function that simply prints a message if a task fails. This helps with debugging by logging as unique identifier when something goes wrong. Now, let us review the core functions of our ETL process: extract, transform, and load. Our extract function reads from findfoods.json and returns the data. Note that we provide a sample list of records directly in our code for simplicity. In real scenarios, you do read from a file or an API endpoint.
Next, our transform function takes the data extracted by the previous task and, if needed, applies transformations. Here, it simply pulls the data from XCOM, but you can expand this function to perform more complex data manipulation. Our load function establishes a connection to MongoDB using Mongo hook and then loads the data. It first inserts the raw data into a staging collection and then runs an aggregation pipeline to transform data types. For example, converting scores to doubles and timestamps to dates, before finally inserting the transformed data into the final collection. If any error occurs, it logs the error message.
Finally, we define the DAG that coordinates our task. We set the start date, scheduling interval, and tag it with findfoods. The DAG has three tasks: extract task, transform task, and load task, which are set sequentially. Now let us see how to run this pipeline using Astro. To start your local Airflow environment powered by Astronomer, run astro dev start. This command builds your Docker image and starts all necessary services, including the scheduler and web server. So I already have it run on my machine. All I have to do is to run the astro dev restart to restart. You can see it has restarted successfully. So open your browser and navigate to the localhost 8080 just like I did. Here you will find the Airflow dashboard. The default Airflow UI credentials are admin. So you log in with the credential admin, then likewise the password is admin, then you sign in. You can see you successfully sign in. For configuration, click on the connection from the drop down list. I already have it connected to MongoDB. So here is how to go about it. Set your connection ID to Mongo ID. Then the connection type, make sure you set it to MongoDB. You can see other connection types here. So make sure it's set to MongoDB. For the host, if you're using MongoDB Atlas, make sure you input this just as you've seen on the screen from the MongoDB connection URI. Then you set your database name, then the database username and password. Port should not be set for SRV connection. In the extra field, we set the SRV to true, SSL to true, and allow insecure to false. Check this box if you're using an SRV or seed list connection, and also check to enable SSL or TLS for the connection. You can trigger your load find foods data DAGs manually by clicking the trigger DAG button. Monitor the logs of each task to see the ETL process, extraction from our sample data set, transformation with the aggregation pipeline, and finally loading the data into your MongoDB database. Our data has run successfully.
After the DAG runs, use tools like MongoDB Atlas to verify that data has been correctly inserted into your collection. This confirms that the transformation pipeline converted the data correctly. For example, turning score values into doubles and timestamps into dates objects.
Astronomer significantly simplifies the operational aspects of deploying and managing Apache Airflow. Here are a few reasons why it is beneficial. Astronomer CLI quickly boots up your local Airflow instance with a well-structured project layout, making it beginner-friendly. As your workflows grow, Astronomer offers seamless migration from development to production. You have full control over your DAGs and integration with various data sources and providers, like our MongoDB example here. With Astronomer's web interface, you can monitor your task, view logs, and manage the entire ETL process in one place. Of course, every solution has its pros and cons. Why Astronomer simplifies many aspects of Airflow's deployments and management. Keep in mind that adding custom dependencies at container startup may sometimes be fragile. It is recommended to build a custom Docker image if you are planning for production use. Let us talk about some best practices for ETL automation. Make sure you break down complex workflows into smaller reusable DAGs, and also use retries, alerts, and logging to manage failures effectively. Leverage Airflow variables and connections for dynamic environment-specific configurations. Continuously test your DAGs locally before deploying them to production. Clearly document your DAGs and tasks for better maintainability and knowledge sharing. Apache Airflow is a powerful platform for automating and managing complex data workflows. By understanding its architecture, especially the concept of DAGs and the various types of operators, you can build efficient, scalable ETL pipelines that drive business success. In this video, we have covered setting up Airflow with Docker Compose, configuring connections to both Postgres and MongoDB Atlas, building and testing an ETL DAG, and ensuring proper user authentication and connection management. Mastering Airflow not only improves your data engineering capabilities, but also opens up new opportunities for innovations in your organization. Thank you for watching, and be sure to like, subscribe, and leave your comments below with your thoughts or questions.